On this worksheet, we are going to practice naming molecules that have the alcohol functional group. The alcohol functional group is an oxygen that has a hydrogen on one end, and the other side is a carbon chain. It's really important that you distinguish an alcohol functional group from a carboxylic acid. A carboxylic acid is a molecule that has a carbon-oxygen double bond adjacent to an OH. That is not the same as an alcohol. So this carbon right here is going to have hydrogens on it or additional carbons or something along those lines, but will not have the carbon-oxygen double bond. So in order to name alcohols, we're just going to build on the naming rules that we've already established. We want to find the longest carbon chain that contains the carbon holding the OH group. So it's not necessarily going to be the longest carbon chain in the molecule, but it will be the longest carbon chain with the OH group on it. And this is similar to a rule that we established when we learned how to name alkenes and alkynes. In that situation, we weren't necessarily looking for the longest carbon chain. We were looking for the longest carbon chain that included the double bond or included the triple bond. Once we've found the longest carbon chain, we're going to number it starting at the end closest to the OH functional group, which is a familiar rule to us. And then once we get that carbon chain numbered, we're going to locate any substituents or branches and name them in alphabetical order, not in number order. Once all of our branches have been named, then we will locate the position of the OH group just by simply saying what carbon it's located on. And then we will name the molecule by changing the ending of the parent chain. Now, I'm not doing a really good job of describing the change that we need to make here. We actually just need to drop the E off of the ending and replace that E with all. So we're going to actually keep the AN part, and we're going to just simply drop the E and replace this with all. So for example, if we had a 3-carbon chain, propane, and it was an alcohol, we would call it propanol, just dropping the E and replacing it with all. Here are a few examples for us to practice. First thing that we need to do is find the longest carbon chain that contains the carbon atom holding the OH group. So that carbon atom that I just highlighted needs to be part of the longest carbon chain. If we move to the left, we're going to include those carbons, and then also always don't forget to look both to the left and to the right. Now we're going to number that carbon chain starting at the end closest to the OH. Once we get it numbered, we will locate and name our branch that is on carbon number 3, and it is a methyl, a 1-carbon branch. Now that we have our branches located, we're going to say the location of the alcohol. The alcohol is on carbon number 2. Now we're ready to name the parent chain. This is a 5-carbon chain, which would be a pentane, but we're going to drop that last E and replace it with all. 3-methyl-2-pentanol. Let's name the one underneath it. So here we are looking for the longest carbon chain that includes or contains the OH. We want to number starting at the end closest to the OH. The OH is the most important aspect of this molecule, so we want to start numbering at the end that is closest to the OH. Now let's name our branch. It's located on carbon number 3, and it is a bromo. Now that we have our branches named, let's say the location of our alcohol. It's on carbon number 2. And name our parent chain. That's a 4-carbon chain, so it is based off of butane. We drop that last E and we replace it with all. Let's take a look at this one right here. This is a cyclic. So here is our longest carbon chain. With cyclics, we're going to give number 1, the number 1 position, to the carbon that holds the alcohol, the OH. From there, we're going to either go clockwise or counterclockwise, whichever direction makes sense. We want to try to get to our substituent as fast as possible. So if we go this way, our substituent is going to be on carbon number 4. If we go this way, our substituent is going to be also on carbon number 4. In a situation like this just simply means that it doesn't matter which way we go. We could either go clockwise or counterclockwise. No matter which way we go, that substituent will be on 4. Now we're going to locate our substituent and name it. It's on carbon number 4, and it is a methyl. Now we're going to locate our alcohol. It's on carbon number 1, and say the name of the molecule, cyclohexane. hexane, except for we're going to drop that E and replace it with all. 4-methyl-1-cyclohexanol. Here's our last example. We want to find the longest carbon chain, and the carbon chain needs to include this carbon right here with the OH group. Let's go from this carbon, let's go to the left as much as we can, and then go back to that carbon again, and then let's also go up, I guess. I was going to say to the right, but there isn't anything to the right. Again, always forget to look to the left and also look to the right, look up. Look in both directions from the OH group. Make sure you look in both directions. Start numbering at the end closest to your OH, 1, 2, 3, 4, 5. This time we have 2 branches. We have on carbon number 3 a bromine, and on carbon number 4 a chlorine. Remember that these bromine and chlorine, they need to be put in alphabetical order, not in number order. B comes first in the alphabet, so it will come first in the molecule's name. The location of the bromine is on carbon number 3. Its name as a branch, we call it bromo. Now we name our second branch. Our second branch is on carbon number 4, and its name is chloro. This guy right here. Now we've got our branches named. We're ready to name the molecule. First, we're going to say that the alcohol is located on carbon number 2, and then we're going to name the molecule. There's 5 carbons, so it's based off of pentane. We're going to drop that last E and replace it with OL. 3-bromo, 4-chloro, 2-pentanol.